we at the Khan Academy take feedback very seriously. We're constantly trying to improve, and we recognize that we are at the early stages. We have a very imperfect product, and we can only hopefully improve. And that's why we're working with as many teachers as we can. Some are directly part of our staff. We have teaching consultants. We're working with some researchers. But I wanted to make this.
Hey Sal, I'm so glad to hear that you're appreciative of constructive feedback, and so I thought I'd take just a minute or two to give you some feedback on some of the other videos. I'm also a big fan of feedback. I, in fact, had the opportunity within the last year to have videos of my own teaching criticized and critiqued by expert teachers around the country. So I find it to be very valuable. I hope you do too. So I teach astronomy, and I was looking at some of the astronomy videos, and I noticed you had a series here of parallax videos, or videos related to the concept of parallax and the parsec. And I think if I understand this correctly, that this was the original video, and then you did a different version of it. So I wanted to look at this second version to start with and give you some of my thoughts on it. First of all, I'd like to start with some of the things that I really liked. I really liked that you started with this initial example of the situation where you first you said you were walking near some trees or running near some trees, and then there were some mountains in the distance. But then you also later said, well, maybe you're driving in a car, and I like the car example, but I mean, in general, I thought this was a really good example. This is one of the examples that I sort of start with when I talk about parallax in my class. So I thought that was really good. And then in most of your videos on this topic, actually, you end up with let's skip ahead. You end up with this general diagram that you have, and boy, I really thought that this was a really great explanation in general of this diagram. But I did have some specific things that I sort of wanted to talk about. Back here, towards the beginning, you were saying something about how, well, when we talk about parallax, and really we're going to talk about stellar parallax, you say, well, let's take a look at our solar system, right? So the part of the solar system that you want to talk about is the Earth and the Sun, right? But really, you're that's the only part of the solar system you're talking about, because then you're gonna jump ahead and you're gonna talk about this star that's out here. So that's not a huge problem, but one of the things about astronomy is getting students to understand those different distances and where things really are in the universe. So if you're sort of tossing around the terms solar system and galaxy and universe and all these sorts of things intertwined in that concept without really being specific about where things are in the universe, then I think that is a chance where students can get really, really confused about those sorts of things. Nevertheless, I really did like this perspective that you had here of we're in the northern hemisphere, and here's your drawing of you at your house looking up. So let's see if we can listen in a little bit.
Sideways because I'm trying to hold this perspective. So this is me looking up.
Yep.
And let's say at this point in time, where the way I've drawn this patch, the sun will just be coming over the horizon.
Okay. Right.
So the sun
Right. Yeah. Um, yep. So
looks like
um,
rotating it this way. It's rotating.
okay, that's good. And you're going to go on and tell us a little bit more about it. So I want to skip a little bit ahead.
Like that. And maybe based on my measurement, it would look like the star. It would look like the star is. It would look like the star is right over there. So it's a little bit.
Okay, so right around this point, you're talking about how the star, this line is you. You say it's you looking straight up, right? But I don't think that is the only possibility for what this is, because in principle, a star could be anywhere along this line, and everything in your discussion is going to make sense, except for you saying that this is me looking straight up. What this line really is you you looking along part of the meridian. And I mean, I looked at the different topics that you had outlined in your videos, and I'm not sure if you ever discussed um, position of things in the sky. And for example, this imaginary line that runs from due north to due south that we call the meridian. But of course, every star will cross the meridian over a 24-hour period. And it's a very useful imaginary line for us to talk about the position of things that are in the sky. So, for example, I mean, what I'm trying to say is that this our example star here that you've drawn correctly, in a sense, at this angle. Why couldn't it be down here, or why couldn't it be up here? I mean, in principle, it could be anywhere. It could appear anywhere to us in the sky along that position. I think that's true. So that really, as a student, I'm thinking, well, where is straight up? Because straight up is the zenith, and that zenith is one very specific point right above my head. That's what straight up is. This could be anywhere along the north-south line. But okay, so that's my main complaint right there. And the rest of the discussion, okay, that's all fine. There was a point in here where you talked about the sensitivity of instruments, and it might be interesting to talk about what the ultimate limit is for the sensitivity of instruments, and why this really only works for the closest things. I mean, you hinted at it, but I think that's something that a student would be relatively curious about. All right, so then I liked those things in the video that I mentioned, and then this video where now you say, hey, let's actually use our knowledge of geometry and trigonometry and what we just talked about to figure out how far these things actually are. All right, cool. Now we're doing some astronomy. That's sort of the goal here. And so I liked actually in this video that you did a really brief rehash of the last stuff. Again, using this diagram, which it's not something I use, but I kind of like this explanation in a sense. And so, this, I will admit though, as a non-frequent user of the Khan Academy, this was actually the first video I looked at, and I got a little confused what the previous video was, because when I went back and looked, there were those two different versions of the previous video. So, but that was more my issue. So now there's this, but you're referring right here to that previous video.
Night field of vision. This is the night field. Let me scroll to the right a little bit. Let's say our night field of vision looks like this, and I'll do it in a dark color because it's at night. So our night field of vision looks like this, and let's say that this right over here is straight up. This right
Okay, that's straight up, so that's the zenith.
here is if we're just looking straight up in the night sky. And just to make the convention, in the last video, I kind of changed our orientation a little bit, but I'll reorient us in kind of a traditional orientation. So,
all right, so that's where I got confused, because maybe it was in the first video, which I did watch, but I thought that you seemed to me like you liked the second video better, and I didn't really see this orientation at all or anything resembling this in the previous video that we were just looking at. So that's where I got confused. All right.
if we make this north, this is south, this will be west, and then this will be east. So when we're looking at...
Okay, so now this is a huge problem. If we think about this for a second, the idea that okay, I can make the top of this diagram be north. That's not a problem. The bottom of that would obviously be south. Then okay, but if I'm using this as a map of the sky, and I were to draw in other stars, like this is the star that you said is right above me. It's at the zenith. Okay, maybe if I'm standing with my back to the north and my front to the south, okay, east is actually going to be over here, and west is going to be over here. And I would really encourage you to draw this out on a piece of paper, like maybe draw it out exactly how you drew it out, and then draw it out how I suggest using it, and then just hold it up and put north in the north as you're looking up at it, put south in the south as you're looking up at it, and see which side east and west are. Right. Okay. So you know this video's or my little video here is running really long. I'm just gonna sort of skip ahead. You know, there was one little part coming up here where you said the sun always sets to the west, and I think you're going to draw in the sun in the east, you're going to draw in the sun in the west, and then I think you're implying that it's maybe not due east or maybe not due west, but it wasn't really clear 100%, and that's a huge misconception that a lot of people have. And this is the sort of thing that we really kind of want to clear up. And I mean, you know, the point of parallax, at least for using parallax to measure stellar distances, is we don't need the sun at all, right? I mean, I see where you're coming from, and based on this diagram that you used, it's a nice reference point and whatever. But if you're introducing these misconceptions, it may not be the best way to go about it. So all right. So then the rest of your video here after you get through this is mainly spent on actually making the calculation for the example that you give, which I think is a great example and a great way to do it. I will sort of say that towards the end, and I mean you spent a lot of time here doing this arc second to degrees conversion. And not that there's anything wrong with it. It's something that takes a lot of steps to do and to explain properly. But this really isn't the point of the video. Maybe this should be a video on its own. I don't know how that would work. But then at the after this, now you're getting into, well, we did this all in astronomical units. Well, that was, yeah, you did it in astronomical units, and now you want to convert to something else. You want to convert to light years. And so again, it's another unit conversion, and really the point of the video isn't about unit conversion. So all right, so I guess I'd sort of like to give you a couple other things that I think you could do to really improve these, because you seem to be on the right track here. I said that one of the things I really liked was that example that you did in the first video I was looking at with this stuff up here. Okay, but other than really sort of briefly mentioning that, oh, hey, maybe there's a galaxy out here, which I'm not sure a galaxy is the best sort of reference that we want to make to measure parallax. I think we want to talk about very distant stars still in our own galaxy, but that don't have any apparent movement, but they appear to be close to the star that we are trying to measure. So maybe we have a really distant star, or a series of them out here, and then in the summer, this star appears to be way up here, next to a star that's over here, and then in the winter, this star appears to be way down here, next to this one, and then that angle, that 2 theta here, is going to be the same as this 2 theta there, and that's really what we care about, and that's really how astronomers would be most likely measuring it is the position relative to other stars, other background stars. I mean, that's isn't that how the astronomers make that measurement? I don't. I could be wrong, but I don't think that they wake up at sunrise on one day and measure the position of every star near the meridian, and then 6 months later look for the stars that have hopped to the other side of the meridian, which is the logical extension for how this would work. Um, but you gave this great example at the beginning about the motion, the apparent motion of nearby things, and the relative non-motion of distant things, but never applied that to astronomy, which is what the whole point of this was. And then lastly, I'll point out there was another fairly good video here about the definition of the parsec and how parsec is this comes from parallax angle of 1 arcsecond, right? But let's see. I'm not sure if let's look at this and because this was a good explanation of that. There was some connection to this, and again, here's our sky description that east and west are actually reversed, like we talked about. But you're using this equation which you derived, but if we measure the parallax angle in arcseconds, then the distance in parsecs is just 1 over p, right? 1 over the parallax angle. And I could be wrong. Does that come up? I would think if it came up, it would come up not at the end of the video, but I would think it would come up at the beginning of the video. And I mean, again, there's a weird conversion between the astronomical units and light years, which is interesting, once, maybe, but you would have to know this conversion to get that, and I don't know. I mean, that's not as useful for what parallax is actually used for. So, like I said, I think you're really on the right track. I appreciate you listening to my feedback, and I hope it was useful for you.